Good day, I'm Dr. T and welcome to my office. So today I'd like to talk a little bit about soap and kind of to tie this in, personal connection. So my grandmother grew up on a farm in mid-Michigan in the 1920s and 30s. And at this point in time, farming was not the same as today. Today, of course, we've got the large agricultural industries, large heavy equipment, monocultures, and thousands of acres of land. Back then, you would be looking at 40, 80 acres. Most families would not have had, an insane amount of land by any amount. And it wouldn't have been monoculture. They would have been growing multiple different crops. And, my grandmother talks about how the field was divided. There was lanes and different things. And those would be shuffled around, including both crops and cows, as well as my great-grandmother's chickens, which apparently there were quite a few of them. It was a two-story chicken coop, at least according to family legend. And in this environment, the goal wasn't to produce one thing, sell it, and then buy everything else you need. It was to sell a cash crop, but it was also to produce a lot of your own needed supplies. And one of those supplies would have been soap. And my grandmother tells about her mother, my great-grandmother, making soap and how she would always make it a little bit on the harsh side. So to understand why it would be on a harsh side, let's talk a little bit about, well, how do you make soap? And soap is going to be made traditionally, and it really, if it is a soap, and I'm not talking detergent here, detergents are similar but different chemicals. Soap is going to be made from triglycerides. They're going to be made from a fat source. You use basically any fat source you want. Obviously, different fats are going to give you different properties. Some of those are going to make better soaps than others. And you're going to remove the glycerin from the fat. And you're going to do that in a reaction known as saponification. And the other reagent you need is a strong base, typically lye. You're going to be looking at sodium hydroxide or potassium hydroxide. Whatever base you use, that is of course going to also impart different properties to the soap. So the manufacture of soap, you're looking at several different factors, as well as any additives you want to put in the soap. Although I'm quite certain from my grandmother's stories, I doubt my great-grandmother was making fancy soaps. So what happens is the base reacts with the soap, and that's going to do a reaction that breaks apart the ester that's holding the fatty acid to the glycerin. The glycerin is a waste product. It can be used in other sources, but not really kind of the homestead, sources. It can be turned into nitroglycerin, other things, but that's more of a chemical industry approach, which is, big business nowadays. But now the soap would split apart the ester. You'd have the fatty acid. Now it would actually be the fatty acid salt. So it'd be deprotonated. And this is the soap. The fatty acid salts are going to be what is known as amphiphilic. They are both hydrophobic and hydrophilic at the same time. The acid functional group, usually what we call the head of it, is going to be hydrophilic. It's an anion. And so it's going to not just be polar, which it of course is, it's going to be an anion, so it's going to be very attractive to water. Whereas the long hydrocarbon tail is going to still be one dispersion forces. It's not going to be attractive to water, and it's going to be hydrophobic. So the hydrophilic head, the hydrophobic tail, that imparts some rather useful properties. So if you take soap and you mix it with water, obviously you start getting the suds, etc. And what's happening is as the soap dissolves in water, it's forming micelles. Micelles are going to have the hydrophobic tails all sticking in, and the hydrophilic heads all sticking out, creating these kind of ball-like structures. The reason you get suds is the hydrophobic tails can actually surround an air bubble, and hence you get this nice air bubble that's stabilized by those hydrophobic tails, creating a layer for the air to, make a nice bubble. Now, the way soap works to clean is that once you make a soap solution, you've got all those micelles, and those can go clump up with hydrophobic, greasy dirt that you want to get off, and by surrounding that, that now takes it and makes a pocket that can then be flushed off and effectively creates a colloid that's soluble. And as such, yay, you can use that to clean your self, your clothes, whatever else you would like. And my grandmother's story about my great-grandmother said she always used a lot of base, and then the next step was to neutralize the base, because you don't want a strongly alkaline solution because that can cause chemical burns in the extreme, or what it will do is it'll take too much of the oils on your skin. It'll actually saponify them. That's why bases are slippery, because it turns the oils on your skin into soap. And either way, this is going to be rather harsh on your skin, so it's going to be very drying. And my grandmother would talk about how my great-grandmother's soap was a bit on the harsh side. It was a little too good a soap because she didn't neutralize the base afterwards. Which, if you're making a nice pH-balanced soap, is something you want to do. If you're making something that's going to be more aggressive soap, then you maybe don't want to neutralize it too awful much. So with that said, there's a brief introduction to soap, and it's a little bit of my family history. And have a wonderful day.